how many of you heard about quantum dot display technology in 2008? How many of you could remember that? So, okay, I see one hand, two hands. So this is really a story of Nanosys, right? So I joined the company in 2008, and since that time, we've been working to bring this technology to market. And I'm going to tell you a little bit about that journey that we were on. We have built the world's largest supply chain for quantum dot materials, basically between ourselves and our licensed manufacturing partners. We make up 100% of all the quantum dot materials used in televisions, monitors, notebooks today. We are the innovation leader with over 400 now patents and pre-grant applications out there in the space. And we make the quantum dots at very, very large volumes. So our factory capacity, over 50 tons of material. To give you an idea, 1 kilogram of our material will satisfy the needs for between 100 and 200 televisions, depending on the size of the TV. And we have a tier 1 customer base that we've built with 3 out of the top 4 brands in CE worldwide using our technology, as well as something like 8 out of the top 10. What our business model is pretty simple. We are a materials company. We manufacture the world's best quantum dot materials, both in terms of quality, price, and performance. We bring those to market with our customer base. Our customer base includes people who then take those materials and integrate them into components and other types of materials that can then be used in the display ecosystem. Those customers oftentimes are not experts in the use of quantum dots. So in many cases, we have actually done the work of integration as well. And so we will license those integration schemes and methods to our customers so that they can in turn use those materials and put them into those components. Here we see one of our manufacturing partners making quantum dot enhancement film, which many people think was invented by 3M, but it was actually invented by Nanosys. We set up the first pilot production line for that, and we actually licensed that to 3M, as well as to a number of our other manufacturing partners, who in turn make that quantum dot enhancement film in very large volumes and send it to the end customers, such as Samsung and many others, who integrate it into display products that are shipped into the market. The display market is our primary focus. As many of you know, it is very large, but within the display market, out of that 232 million square meters of display area that are produced every year, enough to roughly cover Paris and the 7 arrondissements in glass, 72% of that is in TVs. So we really do tend to focus on the TV market. Monitor market is a secondary market, and at this point, we don't really have anyone uptaking the technology into mobile phones, although that's a potential future growth area for us. So what does the market look like today in quantum dots? Well, if we look at the implementation again today, everything that you can buy in terms of a product that's out there is using quantum dot enhancement film. This is a film that replaces the diffuser sheet in the standard construction of LCD TVs with a quantum dot enhancement film sheet. And by switching out from a white backlight source to a blue backlight source and using this QDEF film, you're able to get the creation of this perfect red, green, and blue backlight color spectrum as though you had used an RGB LED backlight, which means that you have very high color fidelity and very high efficiency without the additional costs of managing an RGB backlight and without the additional costs of all the power control and all the other things associated with that. So, very simple way for people to use to make perfect backlights for LCDs. That's the implementation that we have today. This is not the best use of quantum dots in terms of how they can make the most impact on the display ecosystem. However, it was the easiest way that we could convince people that they should think about using quantum dot technology in displays. When we first came with this technology in 2008 and said to people, hey, look, quantum dots are great, they're a very narrow band emitter, they said, well, yeah, but they have cadmium, and they're this, and they're that, and I've never used these materials, and how reliable are they, and all of these ecosystem factors that basically needed to be proven. So we had to find a way to get them into people's manufacturing facilities and get them comfortable with these materials. That's why the film was a great implementation and instantiation, and it's been quite successful. There's close to 100 different SKUs this year from, as I said, 3 out of the 4 major CE brands, all using quantum dots ranging from Samsung, from 8K all the way down to some 43-inch displays that we have this year from brands like Vizio, JVC, and TCL, and others. So ranging across the price point spectrum as well, from 55-inch sets that you can go to Sam's Club today and buy for $379 using quantum dots, all the way up to $3,000 and over premium display technologies from Samsung at form factors 82 and 98-inch. So the technology's shown that it can scale across the supply chain, it can scale across the economic buying profile of people out there, and is really starting to move into the mainstream now. We see that courtesy of DSCC, who thank you very much for putting on the conference again. Forecasting an aerial growth through 2025 of over 23% annually in terms of the use of quantum dots in displays. Of course, we've been at the early side of that so far, and we at Nanosys believe that that growth rate is going to be even higher than what DSCC forecasts. And that can be shown in the actual shipment volumes that we've had since beginning our program. Our first product that we launched, 2014, the Kindle Fire HDX. This is a representative graph showing the volumes that we had. We're now up to shipping in 2019 15,000 kilograms, or 15 tons, of our quantum dot material, enough for roughly 3 million TVs. Will be shipped into the market today from our supply chain in California. And then in addition to that, we have the licensed supply chain in South Korea supplying Samsung, which we anticipate between those two, there'll be somewhere between 6 and 8 million quantum dot televisions shipped to market this year. So really phenomenal growth, 63.4% compound annual. And people often ask, well, but how good of a business is this? This is our gross margins. Of course, we're not a publicly traded company, so you don't have to believe these numbers, but they're true. We're audited by Deloitte & Touche, and our margins have been increasing over the period as we've gone to higher utilization of our factory assets. And we expect to be at 57%, over 57% gross margin this year on those material sales. So what about the future? What's coming next? Well, quantum dots really are, the message I want to leave you with is the perfect emitter. And I know people will argue with that, but quantum dots have intrinsically several key properties, one of which was the thing that drew me to this company and this technology the most when I first heard about this phenomena, is quantum confinement. And so quantum confinement allows us to basically make emitter material at any wavelength within the visible spectrum, as long as it's below the band gap of the starting material that we have at very high efficiency. So very narrow spectrum, that's one of the things, which we can choose the particular peak wavelength that we're going to be at. They're intrinsically very stable materials. They all are ionically bonded materials. These are crystals. They do not suffer from things like fast bond cleavage that phosphorescent OLED will suffer from, because those are covalently bonded materials. They are very high in efficiency. So our quantum yields now are basically at 100%. We're developing new methods together with people like Dr. Paul Elevisatos, how to differentiate between 99% quantum yield and 100% quantum yield, because that's where the materials have gotten to. They're very, very cost effective in terms of solution cost production. They're able to be solution deposited through inkjet technologies and a number of other platforms. And they're very, very bright compared to alternative technologies that are out there. So let's talk a little bit about each one of these characteristics. But before I do, quantum dots also can be used in multiple modes. And so today's mode that we use them in the quantum dot enhancement film is photoluminescence. This is where we excite the dot with a blue photon and down convert that blue energy into a different wavelength with very high efficiency. But electroluminescent use of quantum dots is also a very, very growing topic. And you'll see many papers at the conference this time about that. And I think the following speakers are going to speak about that a little bit. where you electrically inject charge into the quantum dot and force it to emit a photon. But there's a third way as well, which is photoelectric effect, where we can basically receive a photon and then take charge off of the particle. So these can be useful in sensor applications and in things like photovoltaics. So what does the ultimate flexible display really look like? Well, it should have those characteristics that I talked about earlier. It should be bright, solution processable, low cost, and have the right spectrum so that we can service not only very colorful and bright display applications today, but also in the future where new color spaces may even emerge. So in terms of spectrum engineering, we all are familiar with the quantum confinement effect. I'm not going to talk at length about this, but basically with one material such as indium phosphide, we can emit colors ranging from blue all the way up to red simply by changing the synthesis condition and the size of the quantum dot that we make. In addition to that, however, because these are inorganic materials, they've been demonstrated, both in our lab and many published papers, to be incredibly bright. So about the brightest you're going to see OLED materials push to in terms of peak power output or peak light output is around 10,000 nits, maybe a little higher than that. But there are already demonstrations where we have 600,000, over 600,000 nits coming out of QLED devices. This is just phenomenal because the sun, when it comes up in the morning, is 600,000 nits. So basically with this little device, we're able to make something that's so incredibly bright. Now that's got utility, of course, in display. Maybe you don't want to have the sun shining off of your TV directly, but it's got applications in a lot of other areas as well, which I think are very exciting, we're going to talk about coming up. Solution processable, this ultimately gets to cost. So, we can deposit these materials using a variety of different techniques. They've been shown to be compatible with transfer printing. They've been shown to be compatible with inkjet printing. We believe that in the future they can even be made using reverse gravure type printing processes. And last but not least, when we talk about cost as well, these materials basically, because they can be used with much lower cost capital equipment, you wind up with a much lower total cost of manufacturing for something like a QD electroluminescent display, which we're projecting on a 55-inch panel base, would actually be below $100 in the 2022 timeframe compared to a Gen 10.5 OLED, which is forecast to be somewhere in the range of $300. So again, very low cost, solution processable, low-cost materials, all of these things contribute in a virtuous cycle to bringing the cost of the overall displays down. There's also many other applications, though. With these types of capabilities that were just talked about, we have now the ability to make these incredibly bright emitters, these emitters which can be driven electroluminescent by electrical currents and by injecting holes and electrons into the materials. We also have then maybe other markets that we might be able to identify where these could be useful. And there's a number of companies that are popping up in the overall quantum dot ecosystem which are working on these other application areas. And I'm very excited to be able to talk about a couple of those. One of them is a company called UBQD, or Ubiquity. And these guys have taken some technology out of Los Alamos and are using this in a way in which you can use the quantum dots, as I said, in an photoelectric effect mode, where you can gather the light energy coming in and then make a solar cell using these materials. So large area solar cell concentrators is something that both Ubiquity and a number of other companies that we're working with, like Luminescent Devices, or Luminescent Energy, are also working in. And we believe that these materials ultimately will allow for the making of true tandem solar cells, which is to say taking the existing efficient 20% silicon solar cell, building a second solar cell on top of it at very low incremental cost that'll harvest you another 10 to 15% of the light energy. So ultimately, these tandem cells, and some of this technology has already been validated by NREL, are looking at something north of 30 to 35% wall plug efficiency, which is really phenomenal when we think about how we can bring down the cost of solar. Efficiency driver is number one. Another interesting area is, again, in using the spectrum engineering capability of these materials. How can we take these materials and manage light in a way that's more suitable for a particular application? Well, one of those applications is in farming. So yeah, the sun is pretty efficient at growing crops, but again, we're gonna have 10 billion people on the planet, as you all know. Space where we can grow food is relatively limited. We also don't want to have very long supply chains for food because it spoils. So we'd like to be able to grow crops local to the consuming populace, and we'd like to be able to do it as efficiently as possible. And some of those areas, because they're in far northern latitudes and other things, don't really have efficient sunlight throughout the year. So if we can take the sunlight that they do get, which tends to be very rich in blue light, and move some of that blue light energy into the spectrum where plants can use it more readily. After all, green plants, basically because they're rejecting a lot of the green light energy that comes from the sun, if we can move that light energy into blue and red, we can increase the overall crop yield coming from the materials that are grown underneath of things like these quantum dot films that you see here hanging in a greenhouse. Also, because the materials have moved to being non-toxic now and non-toxic formulations, as well as being very low cost, they become practical for this type of agricultural application. Another that, we all suffer from this problem of spending our lives underneath of these fluorescent lights, which aren't great, have a lot of blue light energy, is the emerging topic of circadian lighting. And so how can we take the light energy that's coming to us and basically have it shift in terms of its spectrum throughout the day? Well, one of the ways in which we need to be able to do that is to be able to absorb blue light energy from the LEDs that are creating the photons in the first place and move those longer out in the wavelength, something that quantum dots are really phenomenal at. So by working together with companies like Nanolit, we're able to integrate quantum dots into circadian lighting applications where the daylight that you're going to receive in the morning is similar to the daylight you would receive outside, which is to say it's pretty, cool in terms of its temperature. And then as the day progresses, the light generally tends to get a little warmer, and the light that is emitting the light will generally tend to get a little warmer as well, thanks to the use of quantum dots in the light emitting devices that are powering these types of bulbs. And last but not least, I think a really exciting application is this area of photodynamic therapy or photoactivated medicine. And this is one where conventional therapies have been used with certain efficacy, certain drug treatments, but not great efficacy. Well, what's been found is that if you can activate these materials using particular wavelengths of light, either by causing some exciton energy to occur within the material, which bumps it up to a different energy level and therefore activates a mechanism by which it can, for example, kill a cancer cell, or by selectively impregnating materials so that they do not activate except when exposed to light, then you can selectively deposit those materials only where you want them to be. You can deposit those materials in a wide area, but only activate them by putting the light energy on them. So again, this becomes a very nice way of targeting the light energy, or using targeted light energy to activate medicine. This application really requires very, very bright light. And so again, this is something that today you see this type of LED bank and you have to go into a medical office and you have to sit there, and it's expensive as a result of that, and it has to be a treatment that's billed to your insurance. If we could make such treatments on flexible QLED type displays that were just equally as bright, these could be potentially applied at home, again, directly to a particular treatment area, thus bringing down the cost of photoactivated medicine, by, we estimate, over an order of magnitude, which would really be a very significant step forward. And a lot of great companies working in this area as well. So with that, the key message that I want to leave you with is clearly Nanosys is leading the field in quantum dot technology and quantum dot commercialization. We're a profitable company as of the second half of 2019. We're continue to grow well, and we really think this is an investable market, not just because we're doing well in it, but as you can see, there's a broad base of applications for this technology that are continuing to evolve and come forward, really making this an exciting materials category, not just in display, but as a broad-based material. So thank you very much for your time today, and that's all the time I have.